Hello and welcome back. Today we are going to take a look at the case Knife Thrower by Mikoja Rakotoalisoa. I apologize for however bad I just butchered your name. I tried my best. This was another case from the online rounds. Now, I know by the time that this video comes out, we will have just wrapped up the World Championships in Las Vegas, and you're probably eager to see how to solve those cases. Trust me, those videos are coming. But in the meantime, I want to get these videos from the online rounds out first, and then you should be seeing some of the videos from that competition after I get back from Vegas. Let's take a look at the instructions for this case. Knife throwing is a game where players throw knives onto a board. Points are earned based on where the knife lands. The knife throwing board can be found in the sheet named Board, and detailed instructions for where the knife lands are included in Level 2. However, keep in mind that a throw is invalid if the landing spot is already occupied by another knife. So let's take a look at this board. I'm going to go to this board sheet. Now this is what the board looks like. And it looks all right, pretty straightforward, nothing too hard, except in the later levels, from levels 5 to 7, players start rotating the board. So you see here the board is going to go in a clockwise rotation, depending on how many times, and that's going to help determine where the knives land. So that's an extra added challenge in this case that we, to my knowledge, haven't really seen before, but it's going to be a fun one. Come follow along with me as I see how long it takes to get a complete solve of this case, and here we go. Level 1. A thrower is playing alone. He kept a record of his 20 games with 5 throws in each game. The throw notation is as follows. V, point if the point is valid. N, point if the point is non-valid. Non-valid points are equal to 0. How many points did the player manage to get in every game? So here we have the 5 throws. Now so we see the points are after the semicolon, valid and non-valid is before the semicolon. So let's do a couple of text splits. First we're going to text split after the semicolon. No, not text split, text after. There we go, that should do it. So there we get the scores, but we also need to consider whether it was valid or not. So this is going to be my condition. So text before the same range of the semicolon equals V for valid. So there you see this fourth one is not valid. That's going to give us a score of 0. We can sum these all together to get the answer for this level. By the way, I forgot to mention I am coming over a cold, so I apologize for all the coughing you're going to hear in this video. Level 2. The thrower can throw the knife from 4 different sides, north, east, south, or west. You are given a side in the position of the thrower. You can see the player position numbers on all 4 sides of the board. The player of this game is very accurate and will always throw the knives in a straight line. The knife can only land on the board in the cell that is closest to the player. Check the examples on the right side for which parts of the board the player can hit from each direction. So that's where they hit from the north, that's where they hit from the east, this is where they hit from the south, and that's where they hit from the west. Okay. How many points did the player manage to get in every throw? So we're given a position that they're starting from, and we got to figure out where they hit it on the board. So, ooh, this is going to be fun. I'm going to use the same notation that they used here. So location, semicolon, number. So this will be north, semicolon, and the numbers up there. And then to get the number, so what's going to be tricky is that I need these to be going in one cell, but then also not to consider these down here, but I do consider them on this half of the board. So what I'm going to do is I'm going to highlight this range for north 1. That's going to be my range there, but I'm going to filter that range where the length is greater than 0. So basically filter it for when there's something within the cell. Now I know below that I see a bunch of zeros, but that 0 shouldn't matter. So there, that turns it into 1 number, which is great, but when I go over here, that's going to be 2 numbers. So I want to make sure that I take whichever one is always on top. So I'm going to take the first row of that there. Let's see if I paste these all around. There we go. So we get 27,666, 27,666. There we go. That's working well. Okay, let's do the same for the south side. So we're going to do south and all of these numbers here. And then we're going to do the same thing. So we're going to take, filter this range where the length of that range is greater than 0, but we're going to take the last one this time. So we get 27 again, which is right, then 4, then 27, then 8. Yes, okay, good. So that's north and south. Oh, east and west. Okay, let's do east and west on this side. Let's do west first. So west and all these numbers here. And then we're going to take filter. There we go. Filter this range. Once again, where the length of that range is greater than 0. And we want to take the first column because we're going from the west side. So let's just check here. 15, 8, 11. Yes. Okay, good. We'll do the same thing for the east side. East and these seats here. Filter this range. And that range is greater than 0, taking the last column. All right, there we go. Now to make my life easier, I'm going to turn this into one big lookup range. So I'm going to go position and points. Okay, so let's make this easy by just going north, east, southwest, going into like this kind of circle here. So we're going to start with the north. So let's turn that to call this north range here. Then we'll get the east. And then we're going to call the south range here. And then we're going to get the west. Excuse me. Honestly, I don't know if it matters that I'm doing it in this order, just as long as the position and the points line up. So then the points, we are going to do the same thing. So V stack to call the north points, the east points, the south points, to call south, whoops, and the west points. There we go, and that should get all of our points. Everything should line up. So then when I go back to the case, I could just XLOOKUP this value in this column and return the number of points. And I just realized I didn't copy the board beforehand. I really should have done that because I never trust myself. That matches, so hopefully all of these match, and they do. Excellent. All right, level 3. The player is now throwing 10 knives in every game. His position will vary for each throw. Remember, a point is not valid if the position where the knife lands is already occupied by another knife. How many points does the player manage to get in every game? So now we need to consider where the knife lands after every throw. And, ooh, I did not consider that in this model. But what I'm going to do is, let's add some more rows here. All right, so there's going to be position, there's going to be position there. This is going to be a repeat of the map. So if this cell is blank, leave it blank. Otherwise, let's return the address of that cell. So I'm not doing the same as my normal flat mapping because I don't need to consider the starting position. I need to consider the ending position. And I just realized, ooh, okay, let's see here. I don't know where the whole map ends. Oh, I was so close. Just one more. There we go. That's where the map ends. Okay. So now north, I'm going to do the same as this formula, but I'm going to change the range to consider the range below it. So this range there. There we go. And then south, I'm going to take the same formula here, but apply it to the range below. So it should be from there to, I can't tell if that's 91 or 92. I think it's 91. Yeah, 2121. Yeah, that should be right. There we go. And then we'll do the same thing for east and west. So let's add a couple of columns. Now for west, once again, take this formula, but we're going to change the range to this range here. They're both ending on 3s, so that's good. And although I just realized that ending on 3 doesn't matter, it's the column numbers, but oh well, I think it all lined up. And then this we're going to change to that range there. Okay, and then we're going to add an end column here. So start with the north. to call the north sides. And then I think I did east next. Yes. And then 2 call the south sides. I just forgot to close this one, I realize. And then do the west. There we go. Okay, that gets all of our ends. Now let's model this level here. So L3. Let's see. And then we're going to run our... Oops, that should be B's. G to P is where this one ends. All right, so sequence of 10. Next up is going to be our throw. Okay, and that's where they start. We need to figure out where they end. Well, actually, wait, let's just follow these columns. Points and end. Points, end. Let's look up that from position, find points. And I should be able to do the same for the end. That didn't work because I forgot to lock this one. There we go. And then valid. As we're going to count how many times that this end cell appears in that range. And if that's equal to 1, then it should be valid. So we see here P9 appeared twice. That is no longer valid. So the score is going to be the points here times whether it is valid or not. I just realized that is not a range. So I'll just have to do that manually. 95. Okay, that matches the example. Let's run the whole level. And mine did not. Okay, let's try that again. That one, yes. There we go. They all line up. Excellent. Let's move on. Level 4. 2 players are playing using the same board. They take turns in throwing the knives. Their positions will vary each throw. Remember, a point is not valid if the position where the knife lands is already occupied by another knife. How many points did the winner manage to get in every game? The winner is the one who has the most points. So it's going to be the same thing as we've done before, except the only difference now is that we have 2 players playing. So we need to consider where those 2 players are hitting the board together. So let's go to level 4. And let's go ahead and get all this information. Ooh, I can't highlight that way. Oh well. I'll highlight this way. All right. G to Z now. And I think we could take a lot of this and we can bring it over. So this is now going to be 20 throws that lined up. This is the points. We need to X look up this range there. Okay, that's fine. That's fine. And then there we go. This will count if it's valid. And then player. So we're going to start with player 1, and then it's going to be alternating between 1 and 2, just like that. So let's see how many points we got. So we're going to do sum ifs. We're going to sum the points where valid. Oh, whoops. Okay, right. That's not what I want. Okay, that's going to be doing like that. Is true, and the player number is one of these 2 there. So you get 117 to 185. The question is how many points did the winner get? The winner got 185. That does line up. So we're going to take the max of the 2 points there and run the rest of this level. There we go. Excellent. All right, level 5. In this level, all throws are being made from the south side. Now the players have decided to make the game more interesting and have got a machine that will rotate the board for them. While rotating, the board can only take 4 positions. The initial position, 90-degree rotation for the initial, 180-degree rotation for the initial, and 270-degree rotation from the initial. The tricky part is that the machine records rotations in radians. Note that a pi over 2 radian rotation is equal to a quarter rotation. Okay, so we're using radians for this. So in this throw, we have side position rotation. So let's do side position rotation, and let's split that up between the 3. Now, so throwing, I think I could just, oops. All right, so that's the same as we already had, but it's the rotation that's going to differ. and there's going to be up to 2 rotations. So, okay, so what I'm going to do is I'm going to add 3 more columns. We're going to call this 0, 0.5, 1, 1.5. That's going to represent the rotations. Now, because the board rotates in a clockwise direction, I'm going to draw. So the board is rotating this way. That's the same as these outer positions rotating counterclockwise. So instead of modeling the board rotating clockwise, I'm going to model the positions going counterclockwise. I'm going to put that in these columns here, and then that's going to help me determine where each of these will go. So north number 1, if that's rotating counterclockwise, this will then turn into west number 39. So the numbers are going to change a little bit, but it's going to be west. So I'm going to say west and a sequence from 39 to 1. And that's going to do it like that. Now west 39 will then become south 39. Oh wait, let's do east, because east is next on my list. East 1 will become north 1. So this is going to go 1 to 39, so it's going to be north and sequence 39. All right. South 1 is going to become east 39. So we're going to do east and sequence 39 to 1 there. And then west 1, which is here, is going to become south 1. So this is going to be south and sequence of 39 there. Okay, so that's how that lines up. Now, to do another rotation, I can do an X lookup to do this. So I'm going to X lookup these values from this first column and then return that second column again. So let me I want to do my locking here. So I'm going to keep that. These two are going to lock because you see that's going to rotate. And then when I put this here, that's going to rotate again. So you see I went from north to west to south to east. This is all rotating fine. So now that I have a throwing position and a rotation, let's do net rotation. Right, let me get this pi value out here. So what I want to do is I want to get that pi out of it. So I'm just going to put this pi here. And I'm going to call this pi. So let's substitute in this cell pi to nothing there. So that's going to give me 11.5. I'm going to mod that by 2 to get the net rotation. So an 11.5 pi rotation is equivalent to a 1.5 rotation there. So we're going to be actual start is, oh, now I got to make sure I get this right. Because I believe, oh, right, I got to make sure, do I start here and go there? Do I start there and go here? I think I start here and I go there. So we're going to X look up the south into this column here. And we are going to return, there's going to be another X lookup. Let's see, this is going to be the 1.5. 1.5 there. Find that in the headers. So headers here and return that full column there. All right, so that's going to get us the correct column. That should be the return array. Is that right? Right, so south 8 will actually be west 8. And now let's look for the points. So the points is going to be X lookup west 8. From its original spot, return the points there. Let's lock these in. That didn't lock, but it did take me back. All right, 27 points, that does line up. Let's see if I did all my locking properly. Ooh, it looks like I did. And let's put these in for the answers there. Excellent. Level 6, the player is now playing alone and throwing 10 knives in every game. In level 6 and 7, the ending position of the board in the previous throw is the starting position of board in the next throw. In level 6 and 7, the board can be rotated both clockwise and counterclockwise. Each throw, the player's position may also change independently of the board's rotation. After each rotation, the new orientation determines where a knife lands on the board. Remember, a point is not valid if the position where the knife lands is already occupied by another knife. How many points do the players manage to get in every game? Ooh, okay, so this is going to be a combination of the two models that we've already built. So let's go ahead and throw this in there. G to P for this level. I'm just going to do that so I can see. And let's go ahead and throw, it's only one player, so I'm just going to take this model and put it in there. So 10 throws, we got that. Throw position. Actually, you know what, from this point, let's take what I've got from this model here. let's put that in there. So, oops, yeah, let's move these up. Oh, what happened? I hid that somehow. I don't know how I did that. Shift that up. Okay, so side is, we're going to text put that. Throwing position is from here. Net rotation. Okay, so, ooh, right. Okay, so let's do current rotation because we got to figure out net rotation after all of them. So let's do sum of all the numbers from this row. So it's only going to sum the one number, and we're going to mod that by 2. So that'll give us the net rotation for all the throws together. Now, actual start. Okay, so we're going to take that based off the net rotation. There we go. Points is going to be based off of that. End is we're going to XLOOKUP that and see which cell it ends in. And then valid is going to be whether that's the first time that has happened. All right, so let's see if this works all the way down. Oh, looks like it does. This fourth throw is invalid, which I think is what the instructor is trying to say, although it's too long, so I can't really see. Let's just try calculating the score. So sum of the points where the valid is true. I get 142, they get 142. That's very good. Let's run the data table. Take this back, and everything lines up. All right. Level 7, very hard. 2 players are using the same board. They take turns at throwing knives. Remember, a throw is not valid if the position where the knife lands is already occupied by another knife. In this level, the ending position of the board is the previous throw is the starting position of the board in the next throw. In this level, the board can be rotated both clockwise and counterclockwise. New rules are added to the game. If a player's total cumulative score after a valid throw can be divided by 10 with the remainder being 0, they get an extra throw. A player can make multiple extra throws per turn if both conditions are satisfied after each throw. The game ends after exactly 40 throws. Both valid and non-valid throws are counted. How many points did the winner manage to get in every game? The winner is the one who has the highest points. Oh boy, so now we're combining this with 2 players with this one where the board is rotating, but now we're adding the extra conditions because you know what? This wasn't hard enough. So let's bring this in here and let's see what I can take from the previous model and apply it to this model. So XLOOKUP 8, X that, and return from G to AT. Oh boy. All right. Excuse me. Right. So let's take this model, or do I want to take this model? Let's take this model. Yeah, I think I want to take this model because I think that's going to involve less manipulation. So this is now how many throws? 40 throws. Okay, those are all in there. And we can get this in there. And I think we can get this in there. We can get the current rotation in there. So 12 pi is equal to 0. That's correct. We can get the net rotation in there. Actual start, I think we can get in there. We can get the points. We can get the end. We can get the value. I think everything lines up perfectly. The only thing we need to get is we need to figure out who is throwing. We need to figure out what their end score is. So player, I think, does this always start with player 1? I think it always starts with player 1. It doesn't say, but let's go with player 1. And let's do start score and end score. So the start score for player 1 is going to be 0. That makes sense, but I want to do it in a formulaic way so that when I go to the second row, then it will look up properly. So we're going to XLOOKUP this into the range prior to this and find out the end score prior to this. If that's not found, return 0, and we're going to search last 2 first. All right, let's get my locking in so that'll work as I flow down. I think that does that. All right, and the end score is going to be the start score plus whether this is a valid throw. We count those points there. There we go. All right, and then we need to add in the extra rules. I think it's just one rule. Just that rule. If a player's total cumulative score after, excuse me, after a valid throw can be divided by 10 with the remainder being 0, they get an extra throw. So there's 2 things here. Is it a valid throw? Does their score end in 0, let's say. So, again, now to figure that out, there's two things. We're going to need this is true and mod of their end score of 10 equals 0. So that's going to determine whether they go again or not. Now, if they go again, then go to the player above. Otherwise, go to the next player there. These things should all be able to come down. So we see the starting score for player 2 was 0. That's correct. Then we go to player 1, starts at 5, ends at 20. They get another throw. That throw was invalid, so they don't get another throw. Okay. The question was, how many points did the winner manage to get in every game? We got 325. Oh, we got 325 down there. Okay, so let's get the player's ending score. Does this work? I actually don't know if this is going to work. This is the first time I've tried it like this. Search mode, last to first. Oh, that did work. Hey, how about that? So the score is 325, so we just need the max of those two numbers. Run that through the case. There we go. No, we don't want Q. Don't put Q in there. We want this in there. And let's see. Oh, no, that's not working. That's not working. That's not working. Why is that not working? Right. Did this run? Yes, it did run. Why is that not working? This is because I put a T in there. Let's try that again. Let's try this again. Okay, that gave me much better looking answers. Correct answers. I like that. All right, let's go ahead and take a look at the bonuses. We got 5 minutes to go. Bonus A, in level 1, how many throws are not valid? So the not valid throws are the ones that begin with the letter N. So we're going to do count if, how many of these begin with the letter N? 44, excellent. Bonus B, in level 2, which side is the most used? All right, so level 2, okay, so there we go. We got all these pictures in my way. Right, so let's value be text before the semicolon, and we're going to do group by VV count A. The first one's going to come up as north 8 times. I can't see what the others are, but I'm going to trust my group by function, which is correct. Bonus C, in level 3, how many throws from the east side are valid across all the games? All right, so we're going to go back to level C. We need to count how many of these are valid, how many of these are the east. So count ifs, how many of these begin with east, and how many of these are true. That did not work. Why did it not work? Oh, yeah, because I don't need to start out there. I need to start in there. There we go. Run this data table again. I'm going to find the sum of all these numbers, which is 48. There we go. Bonus D, in level 6, how many throws are not valid across all the games? So we're going to take, actually, I'm going to delete that data table because I'm always worried about data tables. Level 6, we just need to figure out how many of these are false. So we're going to do count if, how many of these are false. Very easy. One's false in this game. Let's run through it. The sum I get is 9. Not a lot in this one, but it's correct. Bonus E, in level 7, how many extra throws are made by player 1 across all games? Okay, so we need to count ifs. How many times does this equal player 1? And how many times is again equal to true? So here we get 1 time for player 1 in this game. Let's run through this data table. And we get a total of 39. We'll put that in. And that checks out. Excellent, excellent, excellent. So a really fun case. Let me go back to the rotation real quick. So I thought a couple ways, like I think the transpose function might also help rotate the board a bit. I actually didn't try the rotate function. Let me just see what happens if I try to rotate. I actually, but I went the, oh, so what I didn't do, what I should have done was I should have copied the formatting. Didn't do that. I'm going to do that this time. Let me try copying the formatting here. And I'm just curious to see what happens when I do transpose of this map here. How's that going to rotate it? Oh, that's very interesting. So what it did was it kept the original display, but it just moved like these 6s up here not over here, which is kind of what I expected. So that transpose actually didn't work. So note to self, be careful with transpose. But anyways, what I did with these seats seems to have worked better. And I know some people have started creating lambdas to rotate things, which probably wouldn't be too hard. Like you would just say something like, so within a map, this is row 1, column 1. 90-degree turn would mean this is in whatever the last row of we just delete that. Whatever the last column of the range, but still in row 1. And that's probably not too hard to do. And I'm sure some people have already developed one after playing this case. But an interesting challenge, a very new and interesting challenge, and I really appreciate that. Thank you, Mikoja, for this case. Thank you, Microsoft Excel World Championship, for letting us play it. Give it a try. I hope you enjoyed this content. If you do, be sure to like, subscribe to this channel. Take a look in the description because I do have some solves from some other players if you want to get some additional ideas on how you might tackle this case yourself. But that is all for today. Stay tuned as I upload the final case from the online rounds, and then after that, we'll get into what happened in Vegas. Stay tuned for that. I'll see you then.
It's the Excel